This is lesson 7-6, geometric sequences. Let's review arithmetic sequences that we did in a previous unit. Arithmetic sequences are ones that have a common difference, meaning that between any two consecutive terms, the difference between those terms is going to be exactly the same. Example of an arithmetic sequence we have here is 1, 3, 5, 7, 9, 11, and so on. We can use A typically to name the terms. For example, in the sequence that we have above, the first term, A sub 1, is going to be equal to 1. A sub 2 would be equal to 3, so on and so forth. We can prove that this is an arithmetic sequence because there is a common difference of 2, meaning that we have to add 2 to get to the next term. And we use two forms of formulas, if you will, to define the arithmetic sequence. The recursive form, which refers back to the previous term, and then the explicit form, which refers to the first term and the common difference. Geometric sequences are ones that have a common ratio, meaning that the ratio between any two consecutive terms is going to be the same. So instead of working with addition and subtraction like we did with arithmetic sequences, we're going to be working with multiplication and division with geometric sequences. The symbolism that we'll use here, instead of D for common difference, we'll use R for the common ratio. Everything else is going to be the same, using A for the terms and subscripts for the number of the term. And the two formulas that we have for geometric sequences, the recursive form is going to be A sub n equal to A sub n minus 1 times R. And the explicit form will be A sub n equal to A sub 1 times R raised to the power of n minus 1. Let's take a look at an example. I'm telling you that this is a geometric sequence, 7, 21, 63, 189, and so forth. I want you to find the common ratio. I want you to write a recursive formula, write an explicit formula, and then find the fifth term in that sequence. Pause the video at this point to give yourself a chance to try it on your own. So first, to find the common ratio, we take two terms and divide them, and we can see that 21 divided by 7 is 3, and 63 divided by 21 is 3, so therefore our common ratio is going to be 3. Knowing that, we can write a recursive formula, and remember, anytime you're writing a recursive formula, you are leaving n alone. It'll also be if you're writing the explicit formula as well. Any formula that you write with a sequence, you leave n alone and fill in all of the other parts. So the recursive formula is going to be A sub n equals A sub n minus 1 times the common ratio, which is 3. The explicit formula will be A sub n times A sub 1, which is the first term, in this case 7, times the common ratio, which is 3, raised to the power of n minus 1. And to find the fifth term in the sequence, we could use the explicit formula, which I've done here. A sub 5 is going to be equal to 7 times 3 raised to the 5 minus 1 power. And so 5 minus 1, we'll do that first, is 4. 3 to the 4th power is 81. And then times 7 gives me 567. If you're having any issues on any portion of this lesson, please make sure you are emailing me or consulting me in class.